Hello, welcome to first lecture of course on corrosion, environmental degradation and surface engineering. You may have heard number of times the system failed because of the material degradation. However, my experience has been with a surface degradation. I believe that it is a more dominating failure mechanism compared to the material degradation. Material degradation is basically a bulk degradation, and somewhat my understanding or my experience has been most of the failure start from a surfaces. It can be a crack on the surface, maybe irregular surface on the surface, some sort of acidic attack, some sort of water attack, some sort of windfall attack. These kind of things will happen on the surface. It will not go directly to interior or inside material. So that's why I give more emphasis on surface degradation. And in maybe say rough figure, I can say 70 to 80% failure of the system happens because of the surface degradation. Failure starts from a surfaces, leads to the material degradation. Only few cases, maybe say 20 to 30%, where the failure will start from inside the bulk and then it slowly reaches to the surface. Again, we will not be in the situation getting much time because the failure will be instantaneous, spontaneous, and somewhat we do not have an interest in that kind of thing. And as per my understanding, if that kind of failure occurs, that means surface engineering has already been done very well or very advanced level. That's why that surface damage has not happened or failure has not started from a surface degradation. So that's why this course where we are going to explore. We will be having almost 33 lectures in this course. We will be examining various characterization methods, because when you do a literature review, you find many characterization methods, many coating methods, and many tools available in the open literature, and everybody is trying to claim that their method, their coating is better than others. So we want some sort of scientific understanding, we want some sort of mechanism to understand how the failure occurs. And many times the failure is happening because of one reason, maybe say because of the surface crack on the surface, and then slowly it moves to the wear side, and the wear again will have a number of mechanisms, and finally failure occurs is basically composite failure. We will not be knowing how and why this kind of failure occurred. So we require a very good understanding about the damage mechanisms. So we will be exploring in this course and about all those damage mechanisms, what are the mitigation methods, how to avoid, how to save the economic cost. In introduction, maybe say the proposal, I covered some sort of economics or maybe say economics related factor, and I say I am giving more weightage on the corrosion, because the corrosion or the cost of the corrosion even in India is almost a 5.95% of the GDP, which is equivalent to 1.667 lakh crore. It's a huge amount, huge even from education point of view, because in 2023 even the complete education budget is just 1.13 lakh crore, which is much higher or much lesser compared to the cost of the corrosion. So there is a need to understand this mechanism, there is a need to understand how do we really help India, or maybe science, or maybe say what kind of contribution we can play to minimize this kind of a cost. So of course, when we know the mechanism, we can really reduce the cost. Now this cost is again have a two components, what we say direct losses and indirect losses. What are the direct losses? We require a regular maintenance, regular cleaning about the system, and these direct losses will be contributing roughly 2.3% GDP. That means if I enhance, I may come up with a better science, if I come up with a better understanding of the method, even this direct losses can be reduced, which is equivalent to 2.3% GDP. It's a huge amount. Now more than direct losses is the indirect losses, like a shutdown of the company or maybe the complete plant. That's a very huge cost. Or with a regular usage of the system, efficiency comes down. Initially efficiency was 99%, maybe after 1 year efficiency 98%, after 2 year efficiency 95%, and actually slowly efficiency is coming down. Naturally there will be a lot of loss because there is efficiency loss, energy loss will be there, which is again not very good economics point of view because it is going to cost a lot. Sometimes we need to replace complete product. This is again another big cost, and sometimes we need to over design the systems. We know that this kind of failure is going to happen. Can we over design? Maybe say factor of safety 1.25 or factor of safety 1.5, which is unnecessary. If we understand science in detail, we understand how to mitigate this kind of failures, we can reduce this factor of safety and we can really reduce the cost. So overall, if we want economic solution or cost effective solution, we should understand this course in detail, and this will be applicable for the many different industries, different organization, different kind of services, and that's why I want to show a slide on that. That's the corrosion which I mentioned, that 5.95%. If you look at that, there are number of sectors where the involved obviously the corrosion is really happening in those sectors. Let us take an example of agriculture. It's an environment, dust is there or maybe the silica particles are there, moisture is there, and both are the very harmful as such if we do not use our surface engineering knowledge. So, agriculture cost almost 6% of the corrosion cost itself is a huge amount. Naturally, another one again a mining, again the particle comes, again some sort of reactive gases will be there, there will be some moisture or maybe some water content, again you are going to cause some sort of corrosion, again this is a huge cost. Manufacturing, we have seen number of times even the manufacturing tool deteriorates with the time, even it will get blunt, productivity will be lost, and that's cost almost a 5.7% of the total the corrosion cost. We have found number of times a failure in oil and gases, which is also contributing 1.5%. Water management is another major problem, because we know the water is itself, it has a flow, and then moreover it has a corrosive nature or it has a rusting nature. So, if we are using some sort of steel or maybe the iron related material, naturally the damage will be huge. Even if we replace with a plastic pipe or some other kind of pipe, water flow will be a major problem. So, we require a surface engineering in effective manner. Same thing will happen with transportation in our automobile, maybe buses, where the major problem comes, even the railway tracks. This is also going to cause a lot failure in a railway track, with regular maintenance is required, and one of the major thing is a high temperature corrosion, which happens in most of the electricity related units, because the temperature is very high, and then again there will be the fly ashes, there will be the corrosive media, which is going to cause a major failures in this case. Of course, this is overall we are showing only the 50%, and there are a number of other sectors which will be failing because of the corrosion. Even in the concrete or even the structures, they are also subjected to the corrosion or environmental corrosion or environmental degradation. So, if you want to really increase the life of systems or components or sub-assembly in this kind of sector, we need to really understand all the mechanisms, we need to understand surface engineering, we need to understand the characterization, how do we come up with a root cause failure of the system, and then we provide a best remedy or best solution in that. In my proposal also I covered one slide on the normal maybe say day to day example. We say that if you keep a car unprotected in an environment, and maybe in one rainy season or one winter season is sufficient to cause a corrosion of that body itself. This is a old cars where mostly the metallic body was used. Now the industry has come up with the plastic of composite materials, which causes a lesser damage, but still causes significant damage. So, what we are mentioning here, quite possible environment itself is a causing a degradation to the system, and because environment is causing a degradation of the surface, and then we need to reject the complete system, which will cause the environmental degradation. So, there is a two-way process. Environment causes a failure or a system is leading to the environmental degradation, and this is a major issue because we know that there will be a lot of the pollution, there will be a lot of the gases which are acidic in nature, or when they interact with the water they form acids, and that cause increase the corrosion rate also. So, these are important. We also covered something like a corrosion and oxidation interaction. Oxidation, where is a chemical process where the some sort of electron action happens, or maybe loss or gain of and then by atom or molecules. Well, corrosion is a bigger domain, and we say that the oxidation is just a subset of the corrosion. So, we want to explain it this corrosion in a better manner. Oxidation is just one of the phenomena, one of the portion of the corrosion. And then we say that even we know how to protect a car. It is a daily way that we simply cover the car, and if we take that as an example and think about the surface engineering, that means how to protect surface from environment, or we can say put a barrier between environment and surfaces. If we are able to put barrier between the environment and surfaces, surface is not going to cause any damage to the environment, environment is not going to cause any degradation of the surfaces. That is a perfect solution. Provide a separation, provide an interface, and that is a course. So, we are saying that we should have this kind of course to figure out what will be the effective way to bring this separation and increase remaining life or remaining useful life of the product or system, and how do we make a environment sustainable. And that is why this first course on corrosion, environmental degradation and surface engineering is very important. If we understand mechanisms related to corrosion, related to environment in interaction with the surfaces and causing corrosion or causing a damage to the surface, then it will be important for us. So, this is a course which we are trying to provide in a detail, and we have divided this course in 5 divisions. We say that many times we observe the surface degradation, that is a visualization, and this may be sufficient, but if we want more and more mechanism to be integrated, to be understood, then in that situation we require more techniques. So, surface visualization is the easiest one, and then based on that there are number of mechanism also been given in literature. So, we will do a kind of literature review effective manner, and then provide some basics basic knowledge related to that, but this basic knowledge we will finally try to implement effectively and then in a cost effective manner. That means, we will also consider which method is going to be very useful in which situation and at what cost. So, if we know the severity of the problem or severity of the situation, we can give a different kind of solution. And quite possible, when we know the fundamentals of the surface failure, we can provide a better treatment, we can provide a comprehensive solution to the system. As I mentioned earlier, environment also causes a failure of the system. So, we need to see how environment is really causing a surface degradation. Water is one of the very common thing, that is why the humidity remains. Dust particle is another one, wind gust is also another environmental factor which causes a surface degradation, and we need to really establish correlation or relation with the corrosion, because they are we will be treating all the failures in a corrosion term, because we know very well corrosion will play a lead role in this surface degradation. Even though we know that wear phenomena, physical mechanisms will be there, but in presence of corrosion, that the acceleration of that wear phenomena is phenomenal, very high. So, that is why we say that corrosion is a lead factor. We will keep it in a lead way, and then we will try to analyze the whole course from that angle, or maybe most of the damage from that angle. We have a number of characterization method. We say that how do we measure the surface degradation? There are number of methods we will be exploring one by one, and actually when we are trying to optimize the surface degradation identification measurement, we should have an understanding of the characterization techniques. Not every characterization technique will be useful in every situation. So, some situations some other characterization technique will be effective. We will take a number of examples and we will try to establish a correlation, and then we will also say that quite possible many times a costly machine should only be used in the final way or final method. It should not be used in the itself at the beginning, because it may not give a nano, we may not require a nano level detail immediately. Quite possible we need to move from macro to micro to the nano level. So, we will establish a network and then try to figure out how a cost effective manner we can identify the failure as such. Once we have identified, then we can do good analysis related to failure. Then virtually we need to find out what are the failure modes. There are number of failure modes, and then what will be the effect of their failure on the life itself. How do we assess that what will be the life, what will be impact of the life on overall system, on how this will be related to economics, or how it will really cause a failure or success or from economic point of view. This will provide overall competitive environment to us. Then we can choose different processes, different materials, and then we can say, yeah, you replace this material with this material and provide a better and better solution. It will cause a lesser pollution, it will cause a lesser damage to the environment. This is a way we will have a utility of the failure analysis and life cycle assessment analysis. Towards the end, towards the last, we will be thinking about how to modify surface to minimize surface degradation. And what kind of the coating, because again there are soft coating, hard coating, and then there is some sort of a method that we call a surface functionalization. Now, in the recent time we have started working on the nanotechnology. Nanotechnology is basically we utilize the nanomaterial in form of a coating or in form of the some additives in the lubricant and maybe say when in the water to provide a good surface protection and then overall good solution to us. So, this is the overall framework of the course. We will have a 5 divisions in the course. Let us take a very common example to understand this. You have seen this kind of the stones. And I say that these stones are also being made because of the surface degradation. Bigger stones, they become smaller and smaller stones with the time, and because of the heavy rainfall and then because of the chipping of because of the water flow, they get a different shapes. So, you can see that this kind of stone also has caused the surface degradation. Coming to the metals, metals can even after degradation can become very porous. Different materials will have a different kind of impact. Few materials are more reactive compared to some other materials, like a plastic is lesser reactive compared to the steel, and then we will find a much faster degradation in the case of the corrosion related phenomena. However, in case of the physical related phenomena, plastic will have a much more surface damage. So, we need to know what is the really right method or right material in this different situation. Even the composites is one of the very good solution as such, but we know the defragmentation or delamination happens very frequently in the composites. And then they are very susceptibility to the UV radiation. If they are in presence of radiation, this lamella may also break in some sort of smaller pieces, and then that causes a major problem. So, if the fibers are broken, naturally the composite material will lose the strength itself. Another thing is that if they are made layer by layer and delamination hackers, naturally that will be also a problematic. So, we need to understand those things. tool, even from age old people or maybe the civilization, they have understood the tools will work only for the some time, they again need to be resharpened. Now, this resharpening is required, reason being that every time because of the surface interaction, because of the corrosion nature of the fluid of the water, these chips will get blunt even under the forces, and then particles will come out. So, sharpness will come and slowly reduce, and sometimes even the breakage also occurs. So, it is not only that this is stone related tools or wood related tools, even the metal related tools also the same thing happens. Another major issue in the surface degradation is from a very we say that from history point of view, whatever the big buildings we have in India, that also causes some sort of decoloration with a time. Reason being again there is an environment which is having some sort of pollution and water, and then that causes some sort of in the erosion from the surfaces, and then we lose a material from a surface. So, we need to understand that kind of failures also. I in one earlier slide already I have given automobiles, but you can see that the automobile has a tire, and when it interacts with the environment, they leave a number of particles. That means, the tire also degrades with the life with the time, and then is really going to pollute the environment. So, if we are able to provide a better and better material for the automobile, or maybe say for the two-wheeler, four-wheeler, or maybe say the trucks, that will really help the environment, and that will really save the cost in this case. We do not have to really spend the money on this. So, there are some major failures which have happened and in what we say, sometime it is very sudden, and sometime the information was given well in advance. Let us take an example of the bridge failures. It is well known that wherever there are nut and bolts which are mostly made of the steel, they will get corroded, they will fail, and that is a major issue with a number of infrastructures. Actually, we require the time management, or we say that we need to have a strong maintenance strategy, particularly for those kind of failures, or to avoid that kind of failures. And we know very well many times we are able to avoid that failure, or regular maintenance is done, but sometime it is sudden, and then maybe the problem occurs and immediate failure occurs. This is another one structure which is showing that in environment, because of environment the rusting happens, and because of the rusting the cracking happens, and because of the cracking and because of the strong wind or rainfall, and we lose some pieces from a structure itself. Naturally, the strength will be much lower in the situation, and the fatal failure will occur. Even in oil cases of the pipe and the oil pipe cases, we have observed a number of the corrosion phenomena, and then because of the corrosion the whole structure becomes a porous initially, and then slowly the layer by layer the material gets removed, and finally the complete pipe is open to the environment, causes a huge loss, not only related to oil or not only related to the passing fluid, but to environment in a very big way. We also have seen failures in the gears, similarly in the bearings on number of components, where we have found that there is some sort of failure, even though people can say it is a fatigue failure, and mostly the fatigue failure is a kind of material damage, material degradation. But we have also observed the fatigue failure start from a surface also. We have seen a number of cracks and the pits on the surface leading to the material failure. So, this failure is basically related to surface, which is causing a surface fatigue and which is causing the material failure. We have covered this example in earlier proposal also. We know that because of the rusting, now even if you try to polish or do the repaint, we will be losing the thickness. When we are losing slowly the thickness of the different parts, naturally what will happen, the material is getting removed from a surface and the failure will occur. So, that is why we required a good surface engineering to avoid bridge failure, to avoid a structure failure, we require avoid a corrosion failure or fatigue failure, we require surface engineering in a bigger way, in an effective manner. Let us take a example, maybe in a better way, or maybe say in more detailed way. We say that every surface, or maybe say, has some sort of a core material also, what we call a bulk phase. So, what we are trying to cover, we say the surface damage, or the damage start from a surface, and finally it will cause a bulk failure. And as I mentioned in earlier, we will say that mostly the failure start from a surface, almost 70 to 80% failure I have seen is related to the surface failure. It is not a bulk failure. Only few cases the bulk failure, the failure start from the inside, or we say that because there was some sort of the material defect and slowly it moved to the surface and surface damage occurred. But mostly the failure start from a surface. Now, surface failure, it may have some sort of sliding mark which happens because of the physical interaction. It may have some sort of a pitting or the surface fatigue phenomena. It may have a corrosive phenomena, which is a chemical phenomena attached, or some sort of as I said in this case fatigue may occur just below the surface layer, but quite possible because of the just below surface layer there is a possibility of intermediate layer. Many times when we do a coating, we need to have intermediate the layer which can attach coating with the main surface or to substrate. That failure also may start, and the fatigue failure may start also from that. Now, if I try to summarize this in this figure, you can say we want some sort of critical performance. So, we are taking a very big factor of safety, and initially performance is in the top blue color line. Now, there are two possibilities if you do not use effectively the surface engineering. One is this black color line, other one is a blue color line. Now, what we are saying in this case is a basically accelerated test which is happening in the blue color line, this one line. We are saying accelerated wear occurs or accelerated failure occurred, and this is the normal failure. Now, if I bring effective surface engineering, even I can see this kind of a failure, we can see here there is a big difference. So, if I am losing here by around 10% and if I made effective surface engineering, I am using and losing only 2%. So, what will happen? I am enhancing the life by almost 4 to 5 times. So, this is what we required effective surface engineering to minimize the failure, and then as possible keep a performance, same performance as initial performance. So, that with the time performance is, we are not losing performance, and that kind of systems are now are in high in demand, and then we require a surface engineering knowledge to effectively utilize, and surface engineering knowledge will be only useful when we know the mechanism, we understand the mechanism, we understand the science behind the failures phenomena in that. So, if we think from the failure mechanisms, we can divide the failure mechanism or phenomena in 3 domains. We can say there is a physical domain or physical phenomena, we can say there is a chemical phenomena and a physiological phenomena. For our course, we will not cover physiological phenomena. For time being, we want to be away from bacteria, from algae and all, which are also happening in agriculture cases, but we wanted to be away from that. So, we will not cover biological phenomena, we will cover physical phenomena, we will cover chemical phenomena, and of course, we will cover all the topics, because in physical phenomena, thermal aspect, because wherever we are increasing energy will come in this relation. There is a physical phenomena, sometimes we call the wear phenomena, even fatigue, which is a surface fatigue, which may lead to the wear also. It is not necessary that only the wear occurs only because of the physical phenomena because of under very high load. Quite possible the surface fatigue causes some spherical particle, and which increases the possibility of the wear, or maybe increases the pit, and that causes a wear also. So, these phenomena may be interrelated also. Sometimes the radiation is also connected to it. It can be a thermal radiation or some sort of other radiation or sunshine, maybe UV radiations, that also causes a problem. And then coming to the chemical side, mostly it is a salt or kind of acid which play a lead role in this. There is also overlap between physical phenomena and chemical phenomena. What we are saying, physical failure assisted by corrosion and heat. So, thermal is temperature is playing a major role, and almost every case we have seen, in every corrosion case, temperature plays a major role. With increase in a temperature, heat energy increases, and that causes a more and more corrosion in that case. So, that is an important aspect. So, in what I am trying to summarize, that the physical phenomena will cover, chemical phenomena will cover in this course, but we will not cover biological phenomena in this course. Now, we as I mentioned, there are other number of mechanisms related to this. What we say, chemical action we will cover, mechanical action, and just to physical action we will made a mechanical action and thermal or heat we say that action. So, physical is a mechanical and heat, while chemical is here. So, biology we are not going to cover. We will be covering the wear phenomena of physical interaction between the surfaces, and there are a number of wear mechanisms which we know very well. Adhesive wear, this kind of, many times we say there is cold junction or cold welding between the surfaces, which happens because of if the speed is low or surfaces are attached to each other, and then suddenly friction increases significantly, then adhesive wear occurs, but we will try to cover in detail. There is another one what we call abrasive wear. Sometimes adhesive wear causes abrasive wear, sometimes particles which come from environment or even the water particle causes also the abrasive wear or erosive wear. So, we will have this is a particle related thing which comes from environment or from one of the wear mechanism, we will cover this. Fatigue wear, again the surface irregularities causes fatigue wear, and then we will try to cover those. Erosive wear is basically again velocity related. If the particles come with a very high velocity and some sort of impingement angle, it will cause erosive wear. Fretic wear is a more very dangerous in the ways, is kind of a silent wear, and what we say that we do not realize the two systems which are connected with each other, and there is some sort of a micron level amplitude, vibration is almost negligible, unnoticeable, that causes a fretic wear. That is why we say that this is the kind of wear which is very fatal, and it does not give a lot of information, does not give advanced information, sudden failure happens, and as per my knowledge many bridge failures happen because of this fretic wear. Sometimes we know that temperature increases significantly, and that causes the diffusion also, and then that is why the melting and diffusive wear will occur. We will cover one by one these topics. Coming to the fracture also sometime it gives a information which is mostly leads to the fatigue failure, is the slow, but we are able to see the banding, we know that very well the fracture is going to happen. We are not able to cover it, or maybe say we will not be able to mitigate or bring back to zero. So, we need to give a special the emphasis on the fracture wear particularly, and sometimes it is a sudden. So, we require a good techniques to understand, and then here the more problem and the more understanding is required, because we do not want a sudden failure, because it will cause a huge loss to the nation, so maybe even causes the human life also. So, that is a major issue, and we need to really think seriously about this one. Coming to the heat or maybe say thermal degradation, they are important. Similarly, radiation is important, and sometimes we say that two together is heat and radiation to play together, and then causes the photochemical degradation, that is a very important. Coming to the chemical, one of the very common thing which I have observed is aqueous corrosion. General is a very common corrosion, because environment moisture will always be there and causes aqueous corrosion. You look at all the structure, they will be having some sort of aqueous corrosion. Any other phenomena, any other the surface degradation phenomena will create a more problem. And one is a local one, maybe at some place some sort of fault remained, and then slowly the corrosion is started from that place. Some sort of extra stresses are generated at that level, or some sort of acidic action, then there will be a problem. Flow assisted, naturally there is the flow is related, and then with the flow, mostly because of the water, the corrosion will occur in this case because of the flow. Sometimes we have a connection between temperature and oxidation. At the high temperature, oxidation will happen much faster way, and then that is why we call even many what we say in the surfaces, they undergo oxidation in fact we say that in a fatal manner. We need to understand those. And sometimes we say that mechanical action, heat and chemical action all together will happen, and that will cause the another kind of the failure. So, we can say the total 4 domains. So, mechanical action, so this is the 1, this is the heat 2, the chemical 3, and then is a 4. So, total 4 reactions are possible in this case, and then we will explore in detail these things. Let us look at some sort of risk analysis, because this complete surface damage analysis is required from risk point of view. We need to think about whether which costly machine should be utilized, or maybe costly coating should be utilized. So, at least we should have a clear idea about the risk management, and risk management can be calculated based on 2, what is the probability of the failure. If the failure happens, what will be the impact of that failure in a cost term. So, we can use some matrix, something like a probability and a consequence matrix. We can say the probability is very low, or the probability A to Z, but the consequences will be almost not significant. So, you can see here without any problem. So, we can use any kind of coating, any kind of the surface treatment in this case. However, you can see here this is extreme risk, that is a red, and top one what we are saying, the consequences will be fatal, very high. So, you can see the B, C, D, even the probability is as increases, that there is a red, more and more red color is coming here, that means they are need to be investigated very in a depth. While in this case you can see here the consequences are not very harsh, even in this situation only if the probability of failure is increasing, then we are going to go with a moderate risk. So, we need to analyze all the system from risk point of view. What is the risk, what is the overall damage possibility, because even we do a surface treatment, naturally it will be costly, there will be cost economics in that, and not necessary that every case need to be undergo through the surface treatment. So, we need to think with the surface treatment, and then which surface treatment which will give a cost effective benefit analysis to us. So, we need to think from a risk management point of view. We will cover those in a detail. Let us take a 3 major issues. Of course, if you go to the literature, even Google, you will find a number of such cases. We know very well the Bhopal gas is the tragedy. We know that this isocyanide was leaked, and that in a huge quantity in tons. And then there were 3 significant phenomena, and the failures were there. What we say, the people to stop, to reduce the operating cost, they stop the refrigeration system. So, this is why I say that in India the cost makes a lot of sense, or maybe say a lot of impact. Whatever you get a best solution, but things may not work, because people say the solution is very costly. So, this is what people the operating system, the operator thought about is stopping the refrigeration system to save the cost. That was one thing. Another one was the gas scrubber, which is really filters the harmful gases. Even suppose cyanide leaks, and then the gas the scrubber will prevent it to move out, but it was also failed. And then people knew about that, but at that time gas was not leaking. So, they say okay, no issue, it is not going to create a more problem. And finally, another one, there was a corroded pipe. So, it is not only one, the 3 subsystems were in a problem, and then together create a major we say that the tragedy for us. Many people died, many people are kind of they got hurt for the long term. One is the short term, the death, but the long term also that they are still going through this kind of problems. So, I am just mentioning that we need to think from a risk management point of view, what will be the consequences. If this happen, what will be the consequences, and then we should think from a solution, and think solution from that strategy. As I mentioned, the many times the bridge failure happens because of some sort of a weak link, or maybe say nut bolt connection, or some sort of a crevices is started there, or in some places some sort of crack is started. So, that we can think, and then of course, it was noticed well in advance, and then this kind of damage was prevented to some extent. We know the derailment of the Charminar Express is, we know very well that if the tracks are not kept well, maybe not maintained very well regularly, there will be problem. Even the railway track comes under the wear phenomena, or maybe the failure happens because of the wear, and we need to think about how surface engineering should be utilized effective manner to avoid this kind of failures. So, these are the important thing. Now, these are the all macro level I mentioned. If you think from a micro level, and I am just trying to show the figure 2, is basically visual inspection. Right? Even I am trying to look at and maybe even the microscope, or to some extent, but visually I can see the failures. In this case, you can see that the pit failure of the field formation has occur, or in this case even the melting, and particularly for ball test, we say melting and then the joining, the resolidification of the molten layer has been visible. So, these are the what we can see visually, and then with the naked eyes there is no problem as such. But we are not interested only in this, because we want to figure out what will be the root cause. Now, if this this surface, this portion, if I enlarge, and then I find that there is a very big surface roughness in this, very high surface roughness over here. You can see the peaks and valleys, and these peaks and valleys brings a lot of discontinuity, and then they also leave a lot of room for the wear phenomena. Now, if there is a water content or environment, some sort of the weathering condition available, then this will enhance the wear rate of much faster this. Even there is some sort of acid, then it will increase the wear rates significantly. So, these are the important aspects to look at. Another one, sometime we use a costly technique, a 3D optical profilometer. That is only required when we know the surface roughness is a very critical, and then we need to find out. Otherwise, we can do the 2D surface roughness measurement, 4-5 location, we can generate the 3D profile from those 3-4 images itself. So, we need to know how to utilize available resources in a much more effective manner, and that will come when we understand the science in the depth, and then we know how to bring a practicality in this. Now, look at that, we want to go ahead with much more detail even in the surface, and now I want to go with a 5 micron level, much lower level, and I can see here some sort of the salt formation, or some sort of chlorine action happening on the surfaces itself. So, in this situation we know this is initiation, and naturally possibility is that the delamination surface will start disintegrating, it will create a wear, and many times so wear itself leads a major failure. So, even though we say that the wear is a very slow phenomena, but quite possible that slow phenomena, if we are able to stop there itself, it will not lead to the major phenomena. So, this is very important, and we can show you here that there are various mechanism. Even the wear mechanism, if I find some sort of long particle, what we call a wear particle is the cutting wear, but here we find some sort of spherical particle which is the fatigue wear. So, even the wear phenomena also can play a major role, but there are multi phenomena. It is not I have studied only adhesive wear, I will say okay, adhesive wear I can deal, but there are number of phenomena. We need to figure out which phenomena is the root cause and how it is leading to the next phenomena. So, this is interaction, and we need to understand that. So, this will be also covered in this course. Let us look at in a slightly different manner what is our role, what should be the role of industry, what should be the role of the government, what should be the role of the user. Why I feel the life cycle assessment should be done by industry, should be done also from government, and should be done by the user also. Why it should be done? Because whatever the product or process which we launch, we need to know what is the goal of that and what is the scope of that. How much raw material will be required, how much energy will be required. Naturally, if I am enhancing the life of any product, I will require lesser the raw material in the long term or lesser energy in the long term. That means, I am going to lead to the useful increase the useful life and going to for the sustainable solution. So, these are the important thing. Another one is raw material and energy, and then if there is a near net manufacturing, naturally raw material will be lesser. Reason being, production, after the production I will be getting the final product in a near shape. I will not require many manufacturing processes to polish to make it in a very useful manner. Naturally, the production process also play a major role. So, then when we have understanding of surface engineering, we know that what kind of raw material, how much energy and how much what kind of process will be very useful, so that it will give very long end of life, and we do not have to think we say the environment, we need to think in environmental pollution point of view, and then we are able to enhance the life and then save or conserve the environment in a better manner. When we do this kind of product, naturally we need to also think about inventory analysis, how much time will be in a store, and then if what kind of distribution, how it should be distributed, and then finally the end of the life product, how it will be disposed of. So, again this is also important from a government point of view, whatever we are making product, whatever the surface engineering we are using, will it be really useful or will not be that be useful. Now, why it is useful or not? Because we know the solid waste is continuously increasing on this earth. You look at any country, solid waste is continuously increasing. How many effective methods we have to dispose of solid waste in an effective manner, and then if we are able to solve this problem, and then how much raw material we have remaining to make it and then continuously use it. Naturally, we need to minimize the solid waste, and that solid waste sometimes we process, but it causes a number of environmental emissions. So, we need to minimize it. We need to minimize emissions. So, if you look at that, the life assessment it becomes a very important from industry point of view, from government point of view, from the user point of view. But we will take a number of examples to exemplify what am I really trying to mention through this slide. So, these are the very important. Now, I will just show you the couple of practical examples which we have done in our the research. We try to look at only in surface roughness, and then we found in the case 1 the surface roughness was something like 0.362 micron. We changed the surface roughness in 0.051 micron, and we found that failure can be reduced by 72%, life can be enhanced almost 3 to 4 times. So, this is an important observation just by treating the surface or not treating, even the polishing the surface in an effective manner. So, these are the important naturally just changing one manufacturing surface in the manufacturing process. If the life is enhanced by the 4 times, naturally raw material is saved, energy is saved. So, life assessment will be a much better in the maybe show the good example from that point of view. I am just taking one example also from a reference and the reference has been given in this. What they did in this case, they do a coating on the wear of the surface, and they found that when they are doing a coating, wear has come down to lesser than 50%. So, this is a very effective manner. That means again that they are trying to save. They are trying to save the material or enhancing the life by 2 times. Then naturally, they are trying to reduce the raw material and they are reducing energy. However, there will be cost of the coating that will be needed to be accounted. So, we really require a good economic analysis and then effective economic analysis to think about whether we should go ahead with this or not, and that requires complete science, that requires this kind of course. And thank you for attending this lecture. We will come up with the next lecture.